Good evening, kids. Welcome back to the course. Today we will discuss about Cartesian coordinate systems. In the last class, we have seen that there are three different types of coordinate systems. One is Cartesian or rectangular coordinate systems. The other one is cylindrical coordinate system. And the last one is spherical coordinate system. In today's class, we'll see about Cartesian coordinate systems. So in this video lecture, we'll discuss about how to compute unit vectors and how to compute distances between 2 points in a Cartesian coordinate system. So on the completion of this lecture, you will be able to compute this unit vector and you will be able to compute the distance between 2 points in a Cartesian coordinate system. Now, the contents of this lecture are divided into, I will start with two-dimensional Cartesian coordinate system and I will extend to three-dimensional Cartesian coordinate system. And next we will try to compute unit vector and then we will try to compute distance between 2 points in Cartesian coordinate system or in space. Now, as you can see on the left sides, this is a representation which we generally use or we have used till our intermediate. It is a two-dimensional rectangular coordinate system where it consists of, if you carefully see, there are two perpendicular axes. This is the x-axis and this is the y-axis. So if you carefully see, these two are perpendicular to each other. Now, any points will be represented in the form of x, y. If you carefully see, where x is nothing but the x coordinate and y is nothing but the y coordinate. Y coordinates. So these x and y, they represent the shortest perpendicular distances from x and y axis. See, this is the shortest perpendicular distance from the x axis. This is the shortest perpendicular distance from the y axis. So these are the x and y basically. Now, this two-dimensional rectangular coordinate system can be extended to three-dimensional coordinate system also. In a two-dimensional system, we will be employing this particular formula where, let us suppose A is a vector. So it is having x and y. So generally we will write it as 2, 3. This is a point in a two-dimensional coordinate system. If you want to write it as vector, then I will write it as, so this is the coordinate in x direction, this is the coordinate in y axis direction. Or in most of the times you will be using I and j also. So I will write it as 2i plus 3j. See, x and y are often, in most of the textbooks, we do employ I and j in terms of x and y. Okay. So, if let us suppose a is represented as 2, 3, then it defaultly indicates that it is 2x plus 3y, or you can take it as 2i plus 3j also. Now, three-dimensional coordinate system. See, three-dimensional coordinate system. Three-dimensional coordinate system employs three perpendicular axes. So additionally, apart from this x and y axis, we will be having a z axis. See, a third dimension, z axis is added in perpendicular to the existing x axis and y axis. And all the three axes will be perpendicular to each other. And they follow this right hand rule. You know the right hand rule, right? If the three fingers, see, this is a right hand, these are the three fingers, thumb finger, index finger and middle finger. All the three fingers, if you carefully see, they are at 90 degrees to each other. And the angle between these two is also 90 degrees. So all the three fingers, they are at 90 degrees to each other. So thumb finger indicates the x direction, index finger indicates y direction, and your middle finger indicates z direction. Now, this is the representation in a 3D system. Now, in a 3D system, as already been said, that there are three coordinates. So, x direction in y and the other one is z. And I may use sometimes I, j and k also. Okay, so if you carefully see here, let us suppose if A is a vector given by 2, 3, 4, it means that the other representations of this A vector are these things in terms of I, j, k or in terms of x, y, z. Okay, so this is a three-dimensional space, three-dimensional Cartesian coordinate system, and if you carefully see, this is a point which is given by x, y, and z. This is x distance from x-axis, y distance, and z distance. Okay. Now, if you carefully see, this is an example how to sketch this 1, minus 2, 3 in rectangular coordinate system. See, this is a rectangular coordinate system. This is x, this is y, and the angle between these two is 90 degrees, and here also it is 90 degrees, and here also it is 90 degrees. So, three axes. Now, see here, this is the point of 1, minus 2, 3. See, this is positive x-axis, if you carefully see, and this is negative x-axis. This is positive z-axis and this is negative z-axis. This is positive y and this is negative y. See, x is in positive but y is in negative, so that's why I have gone to this side, and z is in positive direction. So that's why this is the point. This is the representation. Now, magnitude of a vector. Magnitude of vector is very simple to determine. If you carefully see, now we are going with determining the magnitude of a vector. Now let us suppose A is a vector which is given by, this is the equation of the A vector, and the magnitude of this vector A is represented as A bar. A bar is a vector. The magnitude of A vector, it is represented in this fashion, and it is the square root of AX square, AY square, and AZ square. Now we take a simple example here. Now determining the magnitudes of these vectors. Now I will take this A vector. If you carefully see, magnitude of this one is equal to square root of 2 square plus 3 square plus 4 square. See, this is what I have written here. Square root of 2 square plus 3 square plus 4 square. And it is square root of 29. And for the B vector, square root of 3 square plus 2 square plus minus 4 whole square. This is what I have written. Again 29 I will be getting. And for this one, minus 1 whole square plus 3 square plus 2 square. And it is square root of 40. This is the way how we calculate the magnitudes of the vectors. And coming to the unit vector. A unit vector is a vector of unit magnitude and having a specific direction. For any vector, we can compute the unit vector, and it is always represented in this fashion. So this represents a unit vector of a vector. So how it is to be computed? The given vector by its magnitude. This is the easiest way. This is the only way of determining the unit vector in a simple fashion. Now, let us try some problems now. Now, if you carefully see, A is a vector which is given by 2x plus 3y plus 4z. So, A of u, if you carefully see, it is nothing but the given vector by the magnitude. The given vector is this one. This is what I have written here. And in the bottom I have written the magnitude. Magnitude, you know, the magnitude is square root of 2 square plus 3 square plus 4 square. It is 29. So that's why I have written square root of 29. Similarly, for B, see the B coordinates have been given, which indicates that it is minus 1 x bar plus 3 y bar plus 2 z bar. So that is what I have written here. And coming to the magnitude, what is the magnitude? Square root of minus 1 whole square plus 3 whole square plus 2 whole square. So it is 40. This is the way how we compute unit vectors. And next is determining the distance between 2 points in a space. Now let us suppose there is this is x, this is y, and this is z space. Now let us suppose there are 3 points. Sorry, there are 2 points. One is A, the other one is B, and A point is given by the coordinates ax, ay, and az in the 3-dimensional plane. B has these points, these coordinates. The distance between these 2 points A and B is given by, this is the formula, right? So ax minus bx whole square plus ay minus by whole square plus az minus bz whole square. Now we'll do some sample problem on this one. Now this is the problem if you carefully see. Determine the point, distance between the points. So these are the 2 points. Distance between A and B is given by 2 minus 4 whole square plus 3 minus of minus 5 whole square minus 1 minus 3 whole square. So its value is square root of 84. Now the conclusion now. So for any vector, unit vector is given by the vector divided by its magnitude, whereas distance between the points is given by this particular equation. Thank you. I hope now you are able to compute unit vector for a given vector, and you are able to compute distance between 2 points in Cartesian coordinate system. Thank you.